Welcome to this lecture. Today we will be discussing about the critical points. A critical point in a function is any point where the rate of change, that is slope or first derivative, is equal to 0. These points are also referred to as stationary points. If y equal to f of x, then dy by dx equal to f dash of x, that is equal to 0, is a critical point. So if we are having a function, we need to differentiate it and we need to equate it to 0. This is the critical point. There are different types of critical points. First one is a local minimum point, a local maximum point, then a saddle point. It is also referred to as stationary inflection point. So consider this example. We have a, b, c, d, e, f, g, h. So our function is y equal to f of x. We can differentiate it and equate to 0 at the critical point. That is, slope is 0. So consider the point B and C. So not C, E. So these points are actually local maxima. So we can differentiate it and equate it to 0. Then consider the point this C and G. So these points are local minimum, that is minimum point. Then next consider D and F. D and F. Actually these points are not minimum or maximum. Saddle point will be look like this. In some portion there will be increase. Here we are having an increase. That is saddle point. So here saddle points are this D and F. Then our local minimum points are these 2 points. A and H are the global minima points. This global minima is overall minimum. This A is overall minimum and this H is overall maximum. One question. How will you determine these critical points? So how will you classify the critical points? For a function f of x, one can find and classify the critical point using the following step. First of all, you need to determine whether the first derivative f dash of x. Now set f dash of x equal to 0 and solve for x value. Determine the associated f of x value for the critical x values. Then you can determine the second derivative and perform second derivative test as the fifth step. These are the steps involved in this classification. If double dash of x less than 0, then it is maximum. That is, we will have a concave down curve. So this point will be maximum. And if double dash of x is greater than 0, we will get a minimum point, that is concave up, greater than 0. So we will get a minimum point here. Suppose if double dash equal to 0, if double dash of x equal to 0 or does not exist, it means it is inconclusive. We cannot conclude anything from this. That is, slope is 0. In step 5, if we are having inconclusive, then do first derivative test. It is calculate f dash of x on either side of the critical x value. That is, this is the minimum case. This is the critical value. Here the function is decreasing. F dash of x is less than 0. In this region, f dash of x is greater than 0. So it will be a minimum point. So if in this curve, here in this region, f dash of x is greater than 0. in this region f dash of x is less than 0. So considering the saddle point, we need to consider 2 points in this region and in this region. So in this region f dash of x is less than 0 and in this region f dash of x is less than 0. So in both region we are having f dash of x is less than 0. In this saddle point f dash of x is greater than 0 in both regions. So we are having two types of saddle points. One question. Let f of x equal to x square equal to 3x plus 10. Find all stationary points and classify them as maximum, minimum or saddle point. So first of all determine f dash of x. So f of x is this one. F dash of x means 2. This is x square 2x minus 3. Then next we need to set this f dash of x equal to 0. So this is equal to 0 means 2x minus 3 equal to 0. From this we can evaluate the value of x. X equal to 3 by 2. So now determine f of x for the critical value. That means you need to substitute the x value in f of x. That is x value is 1 by 5. 3 by 2 equal to 1.5. So 1.5 is substituting in this f of x. We will get f of x equal to 7.75. So our critical point is x value is 1.5 and y value is 7.75. Now we need to classify whether the critical point is minimum, maximum or saddle point. So from the first derivative we will get the critical point, and from the second derivative only we can classify the critical point as maximum, minimum or saddle point. Now we need to determine the second derivative. So in the first derivative our equation is 2x minus 3. So we need to differentiate d by dx of 2x minus 3. So here only one x term is there. So we will get f double dash of x equal to 2. Now perform second derivative test. So calculate f double dash of x for the critical x values. F double dash of x for x equal to 1.5. Substituting the value x equal to 1.5 in f double dash. Actually f double dash is 2 only. So then f double dash of x equal to 2. So this is greater than 0. Greater than 0 means that critical point is minimum. So which is our point? X value is 1.5 and what is the y value? Y value is already known, 7.75. So our critical point 1.5, 7.75 is a minimum point. Another question. Let y of t equal to minus t cube plus 75t. Find all stationary points and classify them. So first we need to find the derivative. So what is the equation to find the derivative? D by dx of x raised to n equal to n x raised to n minus 1. Remember this point. Okay, differentiating we will get minus t cube equal to so power term minus 3 into t square plus 75. So after differentiating it we need to equate it to 0. So that is the second step. From this step we will get the value of t. Then substitute the value of t in y of t. So we will get the value of y. So our critical points are here we got two t values. So we will get two critical points, one with 5 and the other with minus 5. And our y value is also we got two y values. If we substitute x equal to 5 in this equation, minus t cube plus 75t, we will get 250. And if we will substitute minus 5 in this equation, minus t cube plus 75t, we will get minus 250. So our critical points are 5 250 and minus 5 250. So next step is to find the second derivative, that is y double dash of t, that is equal to, we need to differentiate this term minus 3t square minus 3t square plus 75. So differentiating this we will get minus 60 plus 0. So next we need to substitute the value of t. That is we already know the value of t is 5 and minus 5. substituting the values, we will get minus 30 and 30. So minus 30 is less than 0, so that point is maximum. 30 is greater than 0, that point is minimum. So we have 2 points. One is 5 minus 5 250 and the other point is minus 5 minus 250. So we have local maxima. So these are the points. This point is 5 250 and this point is minus 5 250. So this is local maxima point and this one is local minima point. We got here this minus 30 is maximum. Minus 30 is maximum means minus 250 is maximum. Next, one more question. Let P of W equal to W raised to 4. Find all stationary points and classify them. First derivative P double dash of W equal to differentiating W raised to 4. We will get 4W cube. So equating it to 0, we will get the value of W equal to 0. So this is the critical W value. Once we substituting this W equal to 0 in this equation, PW equal to W4, we will get this is equal to 0. So what is our critical point? W value, that is 0. X value is 0. What is Y value? Y value is also 0. This is X value, that is W value, that is 0. Then this is P of W, that is also 0. So this is 0, 0 is the critical point. Now next aim is to differentiate the 4W cube. So we will get 12W square. Equating it to 0, we will get 12 0 square equal to 0. So it is equal to 0. That means it is the inclusive condition. So we need to go to the step 4. What is step 4? So we got W equal to 0. We need to consider one point before W equal to 0 and one point after W equal to 0. So choosing W equal to minus 1 and 1 is enough. And we need to calculate again the first derivative. P dash of minus 1 equal to, what is our equation? Equation is 4W cube. That is, we need to substitute the value of W as minus 1. So 4 minus 1 cube equal to minus 4. So we have a negative slope, that is minimum. Again, P dash of 1 equal to 4, we got a positive slope. So there is one negative slope and one positive slope. So this value is, this point is 0, 0 is a minimum point. So we will get a curve like this. So this point is minimum.